high water activity will help all those things go away. However, high water activity does not mean that those are not present in the coffee bean. It's as it sits right now. High water activity means they're likely to disappear soon. That was one of those moments where I stated something probably a little bit too strongly. I think high water activity means those things are likely to disappear soon. On the flip side, low water activity tends to occur in past crop coffees. It tends to occur in old and otherwise dead coffees, i.e. things that do not have lipids left to oxidize, sugars to consume, acids to release. There it is. Sugar browning. This is a little bit curious. Browning reactions increase. This is enzymatic and non-enzymatic browning reactions in all products increase with water activity up to 0.6 and 0.7. I would suggest, and I frequently do suggest back home, that even 0.6 is too high for stable coffee. However, this gets back to that sort of like cost-benefit or the risk analysis. If you want to have like browning reactions in your coffee, then you need to have some water activity in there. So you're looking at like water activity being too high and tending to be a risk for the ongoing presence of those sugars, and you're needing some water activity in order to actually roast your coffee. So one of the ways that I like to think about it is stability versus vitality, and with that, Ethiopia and Colombia. And we go right into here. This is just a few little origins that I pulled to look at. And Ethiopia and Colombia, you can see Colombia is not faring too well here, particularly over time. We're getting nice high pre-shipment offer scores. On average, this Colombia bucket's pretty large, so there are some containers in there. That's pulling this down. Generally, we're still getting pretty decent arrivals, and then anytime in the warehouse, and they're not faring as well. Whereas Ethiopia, we just finished this up, and these coffees all, I mean, they just coasted. They did really nice. The difference being that Ethiopia descriptors tend to be elegant, delicate. Even when they're intense, they have a certain refinement. And at least from Colombia's that we like to look at, they have this real intensity. They're the ones that get vibrant, lively. And, well, if we go right next here, we can see Colombians, even starting at 5.8, we're seeing a big bump in water activity, and then a drop down. Ethiopia starts considerably lower. It has a big bump, but even when it bumps, it doesn't get up to 0.55, and then it settles out a little bit. So the question being water activity and coffee quality. Well, let's look at this. Score and water activity by origin. So this is what we're looking at here. Score by origin. We've got Brazil, Colombia. A few things up here. You can just look across them really quick, and you see like, okay, well, you expected Kenya, you expected Ethiopia, Costa Rica, Guatemala, you expected that. It looks pretty normal and regular. When you look at the water activity by origin, you see it's like it's all over the map. And particularly what I'm referring to are the patterns. You see Ethiopia starts at its lowest point, pops up, settles out. Colombia starts in the middle, pops up very high, and drops down a bunch. Two that were very similar, Costa Rica and Guatemala, in score, have quite different water activity profiles. And Ethiopia and Kenya, again, very different profiles in terms of water activity. So it's difficult to say definitively how this shakes out. Got some charts. We've looked at a few of these already. Average score range and the score HAW. This is a chart, and you have to ignore that big bar and the 0.7, 0.75, sort of a fluke coffee, and there's only one coffee represented by that bar. Now, I've got, actually, we should pop here really quick. So one of the things that I'm doing to track these guys is I'm giving everything a marker. And so 1 is always a pre-ship, 2 is always arrival, 3 is against spot, and 4, if it occurs, is against spot. And where that comes into play here is round 1, 2, 3, 4. So at these water activities, this is the average score in the first round in the initial arrival, and again in the second spot cupping. And this is actually relatively regular. You can see with this exception, when it's a little bit older coffee and the water activity is still very low, this is more indicative of a past crop coffee, a dead coffee. Otherwise, you kind of see the same little step pattern going right on down. Now, another way to look at this is by day ranges. And so now each bar represents a little water activity range. And again, you see a relatively regular pattern running through the stuff. And again, as you get into slightly older coffee, that low water activity suddenly becomes a flag for something you don't really want. Shelf life. So answer here is probably it does. I gave a presentation internally to the company, and my boss, after looking at one of the charts, said, "Well, it just looks like coffee gets bad after a year." And it kind of does do that. It looks like that, and well, you see the chart in a little bit. So now we're talking about viability, so-called, with respiration and storage, microbials, lipid oxidation. I promise that chart's coming up. Enzymatic activity. Moisture content is just moisture content. Technically, it doesn't do anything besides sit there. Not related, even though you get like expiration dates on bottles of water. Really, moisture content is just moisture content. Now, water activity and moisture content correspond closely, and in fact, in coffee, in green coffee, they correspond really closely, like this closely. Across the bottom, we have, it's expressed in decimals, but these are moisture content ranges, and going up the side, we have water activity ranges, and you can see with one little fluke here, a very regular progression of correspondence. So we'd say technically moisture content is not related. However, barring everyone going out and getting a water activity meter, you may find that moisture content correlates closely enough to be of use. And here's this idea, going back to the technical thing, moisture content as a actual substance, medium, water activity as a movement. Migrating moisture, so this water is a solvent, and it will carry things. It will activate reactions and charts. So score and water activity by HML, HML2. These are interesting things. We put flags on all pre-ship offer coffees with this HML structure. Now, you can see the codes on the side here, HH, HL, LL, MH. The first letter represents water activity. It's either high, it's low, or it's in the middle. And the ranges for high got set at like 0.59 and higher. In the middle is all the way down from 0.59 to 0.35, and then low is just very low, and you can see how the lows just got cut out by that. Moisture content, I've got just high and low, and that's based on 12% moisture. If it's over 12, it's got an H. If it's under 12, it's got an L. Now we flagged coffees at the pre-shipment level with this HHHL MH type code. So here's all the coffees. They're all right here at round 1, pre-shipment level, excepting some of these guys. Now, what we did was we flagged them with these codes, and then we kept the codes attached to the coffees as we cupped them again and again, because what would happen is sometimes you'll have a coffee that starts in one code, HH, and then it sheds a bunch of moisture, it reduces its water activity, and suddenly in round 2, it would be an ML. And so it's like, well, how are we going to be able to see what the HHs do over time? We did that by flagging them and keeping the flags attached to the coffees no matter what they did subsequently. And what we see here, this MH and ML, this is, these are both coffees regardless of the moisture content, because we have an H and an L. with that mid-range water activity. And you can see as we're starting between 85 and 86, as we get into arrival time, both of the moderate water activities are starting to see some separation from the higher water activities. And by about 200 days, we've got even more. And in fact, those MHs are holding up even better than the MLs are, which just goes to suggest that that little band of slightly higher moisture might be of some interest. Like that MH is looking at up to maybe 12.2% moisture, 12.3% moisture, stuff you wouldn't necessarily want to mess around with. HML, that's HML. Here's HML2. However, we did this other thing where we did the same flagging system, but then we pinned a new flag onto round 2 to see what happens when water activity starts out relatively okay and then it spikes on arrival, because we saw a few spikes on arrival. Sometimes those correspond with score spikes as well. And what we saw here was that if, and this is where it comes in, if you have a water activity and a score on your pre-ship, and then you have your arrival and it spikes, and you might see a score spike or you might see a stable score, you say, oh, well, it's fine, like water activity is wrong and the score is fine, so the coffee's fine. Except that what we have seen is that given that spike, so in these, the MH is a little rise, ML is a little dip as water activity is spiking, over the next few months, we see like really massive drops in cup quality. In fact, we are subspecialty at 3 is roughly 7 or 8 months. So what that would mean is, like, if you see that spike in water activity and the coffee is still good, that means roast it now, basically. Don't try to nurse it out over any sort of amount of time.
I'm sorry, Ian.
We're out of time.
Looks like we're going 7 minutes over time.
All right.
So maybe if we can make some really conclusive, absolute statements.
Yeah, definitely.
But maybe if we have maybe 3 questions or something like that,
Yeah,
we could do that eventually.
Yeah.
So
Please.
sorry about that.
No, that's fine.
So anyway, you like to wrap up the whole testing you've been conducting?
Oh, I thought we were going to do Q&A.
Yeah, we can go. Yeah, but
yeah.
I thought you just want to sort of round up eventually.
So we think that water activity is going to be actually very, very useful. We're still collecting all kinds of data on it, and we're moving into doing more water activity through drying at origin stuff to see if we can find profiles, to see if we can find differences in varieties and origins and how they react to water activity. Sorry, man, I put all of these like dumb animations in, so it takes all this time just to get to my wrap-up screen. But let's do this. The alternatives. Technically, there are not alternatives. There are specific measures. Practically, there are alternatives. I would like to suggest strongly that importer relationships